Welcome back to Easily Explained, where today we will be talking about the scientific method part 2. In this video, we will continue the scientific method cycle, but we will be focusing more on steps 5 through 8. So let's get started. In step 5, you design an experiment. So you need to keep in mind that when you're designing your experiment, you need a control group. Your control group is like your standard. It is the thing that you're comparing it to because you didn't change any variables. Your experimental group is your changed variable. The thing you're trying to prove has some sort of effect on whatever you're testing. And of course, you need your independent and dependent variables. So basically, in this step, you are trying to create an experiment that will prove the results that you are looking for, that one certain variable, your experimental group, that you're going to change in some way is the entire reason of a specific impact that you are looking at, and no other variable had any effect on that. So that is like why you need your control group. In step 6, you are gathering and presenting data. So this is when you actually get to run your experiment and collect data. Preferably, you want to run the experiment multiple times rather than just once, because you need to be able to make sure that those are reliable results that occur somewhat similarly every single time you run the experiment, and they weren't just caused by some sort of issue or problem. So here you're going to run the experiment, you're going to collect data, maybe in a data table, and then your data can either be qualitative or quantitative. Qualitative is your qualities. They're not numbers, or so qualities would be something like maybe color or did it react, while quantitative would be numbers, and this would be the data that you would most likely make in a continuous or broken line graph. And remember, dry mix, dependent, responding y variable. So that was your dependent, and it'll go on the y-axis. And then your mix, m is your manipulated, I is your independent, x variable. Now in step 7, you will analyze your data. And your graphs, your tables, you're going to see some sort of trend or pattern. So you're going to ask yourself the question, is this data supporting my initial hypothesis that we made in step 4? Now here's when you kind of can decide whether you want to reject or keep your hypothesis. And from your new data, you'll probably be able to ask yourself any new questions that maybe you want to kind of start over with another experiment, or just any other things that you might want to fix or do another experiment on. And finally, step 8, the last step, is kind of your more formal lab report write-up and eventually publishing it or sending it to a journal. So we're just going to go over the basic structure of a lab report. This is usually the same for most lab reports, but obviously some things require more detail, and so this is just a basic structure. First, you want your hypothesis. You want to state your claim right away. Then is your background. Same as step 3, you're basically just going to explain the problem and kind of explain some of the background research you already had. Then you're going to do your materials and procedure. Pretty self-explanatory. You're just going to write any materials you used, and you're going to write out every single step of your experiment. So that was like what you did during the designing stage. Then you are going to present your data. Preferably you want to have a bunch of tables, maybe at least 2, and some graphs. And then your analysis, as you did in step 7, you're just going to explain how the data is supporting your hypothesis. And then conclusion is the one thing that you have to kind of go past these steps. This is like the new stuff. In your conclusion, you're going to kind of restate the issue and decide whether your hypothesis is correct, what you did here, but you want to explain more over here, like why is your hypothesis correct? Maybe just a little summary, and then you want to describe any new questions you got, and how maybe this would affect the real world or real life, why it's important. And maybe also this would also be the place in your conclusion to describe any possible errors that you might have made in your experiment, and to maybe warn other people to be careful of these when they want to retest your experiment. And just some other things. Usually lab reports are written in APA format, so maybe look that up if you're not familiar. And definitely, just like we did in the hypothesis, you don't use personal pronouns. So don't say like I think, I believe, ever. You just want to state the information. Those are just some things that are coming to mind right now about just be careful how you write your lab report, and then publishing it to a journal or a formal research paper to get your work out there. Alright, so now we've gone over all of the steps of the scientific method, so we're just going to go over the cycle one last time as a brief layout, and then you will be done. So first you have your observation, using your 5 senses to ask a question, which is your next step, coming up with a problem, your background research, designing an experiment, writing and gathering data, analyzing the trends of the data, doing a little bit more research, then you want to publish your data. And then usually your lab report can lead to some more observations, more questions, more research, design, data, analyzing more research, publishing, and so the cycle goes on. Congratulations! You are now an expert on the scientific method. We hope this video really helped, and we'll see you guys next time. Bye!